So, since there's a fair few people in already, I think it'd be cool to just start off now. The idea with these Wednesday visits is that we kind of just want to get together, probably same time on a Wednesday, get together and just shoot some ideas around. We had a good one yesterday, last week, and we just decided that it'd be cool to like dive right into it and do a bit of a run through. And Sem has very kindly said that he would do a run through on Niagara. So I guess that's why a lot of you are here. You've been like, oh, Niagara, awesome. But the idea with the Wednesdays is that we sort of get together and just share notes, share things that we've learned. So maybe a really cool thing to do after this first week, after we've had some cool tips from Sem, would be to maybe come back next Wednesday, share things that we might have learned, and share some cool things that we've made after learning this stuff. And hopefully things can sort of roll like that. I think we'll try and do a nice big talk, maybe once a month or once every 3 weeks or something. So that'll always be promoted out, so watch out for those. But after each sort of presentation, we'll have a couple weeks of kind of cool off period where we can just share some notes and share some ideas around what we might have learned in the previous sessions. So you're all here to learn some stuff about Niagara, and we've got the lovely Sem Schreuder in.
Hello.
Here he is.
Here I am.
Me and you have had a couple chats before, haven't we, about some of the awesome work you've been doing. But yeah, basically Sem being a mad creative coder, sort of VJ, visual programmer. Did you want to
Doing
just...
cool stuff with pixels.
Yeah, exactly. And so the idea here with your talk today is to go over some Niagara stuff, but then also go into changing Niagara things in blueprints as well. Is that right?
Yeah, so getting more interactivity with your Niagara system. So basically, a lot of Niagara systems tend to be kind of static, and I want to show a way of, basically, interact, have actors interact with your Niagara system. Yeah, sure. Let's check it out. This is the first time I'm sharing my screen through Discord, so
No worries.
so I am sharing my screen, and if anyone can tell me if they can actually read what's on my screen, that would be helpful. Ready? Okay, cool. So yeah, I can basically dive into it. I have prepared a little bit of something. 1 second. So basically, what I've been asked to do is before in earlier projects is to basically create an interactive particle system, and so I wanted to kind of showcase some of these projects. So this was for a TV show. There was this band performance, and we basically put the lead singer behind this kind of mesh screen, and we project visuals onto the mesh screen, so you can still see the see the singer, but also see the visuals in front of him. And basically, what I did was I installed a Kinect, and I made a blueprint that sends the Kinect data over to Niagara, and Niagara does cool stuff with the movements. So here you can see the I was lucky that the singer was moving around a lot, because that really helps. If someone's standing still, then there is no interactivity. But yeah, so that's one example. Other one is a demo I've made earlier. This was the first time that I started working with, basically interactivity. This is also with the Kinect, and I found out a way to, move particles around just by hitting them. So yeah, you can already kind of imagine what happens if this image was to be projected onto the same wall. Then I could basically just yeah, hit particles and kind of interact with the particles while they are being projected onto the same wall. So I wanted to kind of show everyone how to set up the pipeline for this. It's not that hard, but yeah, let me just show you what I do. I
Yeah, I love
hope it
that
doesn't
sense
have
of,
to compile.
yeah.
Hmm?
You've also almost got like a virtual production sense of back and forth there with the you being in the physical space, interacting with the particles, and then if you laid those back over, yeah, got some real simulation sense there, which is nice.
Yeah, yeah. Whoops. That's one of the fun parts about rendering in real time is that you get to interact with your visuals, right? So that's mainly one of the first things that I want to do is just find a way to either connect it to audio or connect it to my hands or connect it to anything. And yeah, that's what I've been doing basically, how to connect everything to everything.
Yeah, makes it really
Um,
fun. Yeah.
yeah, that's at least that's the fun part for me. So I set up this quick scene with this cube that consists of thousands of other cubes. And if I press simulate, I have an actor here, just a sphere. And if I drag it around, I hope that everyone can see this clearly. If I drag it around, then this sphere is interacting with my particle system, right? So the outside world is actually interacting with with the system. And right now it's a sphere, but yeah, in the other examples, there was no sphere because I only needed the vector locations of the Kinect. But this could be anything. You could animate this to audio, or you could basically, yeah, grab anything from Unreal and send it over, or use the data in Niagara. So, basically, what I wanted to do is recreate everything from scratch. So let me just delete this and delete this and keep the world stuff. And yeah, let's make a new folder. Call it, um, I don't know. This is always like the hardest part for me is to come up with names for all these assets. Let's see. So I don't know. Tutorial live.
In my computer with the Unreal naming convention. It's actually really good for organization. Got your own prefix.
It helps. I actually I do that as well. Like I use kind of a naming convention that I saw other people use. That's basically beginning with either BP or Niagara System NS, but then I do underscore SH, and the SH is basically to mark it as my own. That helps for when I'm searching for stuff. So if I'm looking for stuff, especially when you're working with like 20 other creators inside one Unreal project, then you have like hundreds and hundreds of assets, and then the search bar becomes really handy. So that's also why I use these initials, just in case anyone was wondering about that. So yeah, basically what I do is whenever I start to create a new system or particle system, is I create a blueprint and a Niagara system, and I shove the Niagara system into the blueprint right away. So let me first create a blueprint, BP underscore sh, I don't know, do lots of cubes, and I drag it into the level. basically set it at 0, 0, 0. And I create a Niagara system. It doesn't really matter which template you use. I always start with this template. That's just a workflow thingy I've implemented myself, but you can grab any of these. But I mainly pick out hanging particulates. It's just an easy starting point. Hit finish. And this is going to be lots of cubes. All right. In the blueprint editor, actually, I normally work on 2 screens, so I have to improvise how to work on 1 screen. But yeah, let's add the Niagara system into our blueprint. And then we should see some particles in our level editor and in our blueprint editor. Cool. So first, let's actually render some cubes instead of sprites. Well, first thing, because I have a beefy GPU instead of a heavy CPU, I'm going to set it to a GPU compute sim. Let's also hit fixed bounds, and I'm going to set the fixed bounds to minus 10,000. 10,000 minus 10,000. This is so that your GPU knows what the bounds are of the particle system. If the particles actually go outside of these bounds, then the whole system will start to glitch. So in order to prevent some flickering, you can set these values, the bounds values, to minus 10,000 for min and max 10,000 as well. Tune.
Before, like when you look away and it goes out of the viewport because your bounds are not looking at it, all the particles disappear.
Yeah. Yeah, so you fix it by increasing the bounds like this. But I think that you will also use more video memory just by increasing these bounds. It makes sense. I could be talking out of my ass, but I don't know. So at least you'll prevent some flickering and some glitching by doing this. So instead of sprites, I want to render meshes. So let's add a mesh renderer. Right, I need to set a mesh. Cube, so many cubes. Cool. And now let's actually change the initial scale as well. So just go to initialize particle, set the mesh scale attribute to unset, or set the mesh scale mode to uniform. Otherwise, your meshes will just disappear if you try to scale them down later on, which is kind of silly. But let's leave it at 1. And then in the particle update stage, this runs on every frame for every particle. We can just add a mesh scale size module. And then instead of scaling it with a vector, we can scale it with a float. So we can go from vector to float. And now we have 1 float with which we can, control the size of these cubes. So if I set it to 0.1, they are smaller and better. And now if I increase the spawn rate by a lot, let's say 7,000 for now, then it kind of looks like a blob of cubes, right? Right. So in the blueprint, I want the Niagara system to actually cast some shadows as well. So I can go into the details tab and hit cast shadows. Now it looks even better because they cast shadows. They interact with the lighting system in Unreal. So at this stage, what you can do if you want to have the particles basically So if you want to scale the particle systems, let's say I want the particles to also spawn just at the end, at the bounds of this floor, then you could grab the blueprint, scale it up. You can, in the blueprint, you could kind of scale the Niagara system, but that's not really the neat way of doing it. The neat way of doing it is by changing these locations. So basically, the template comes with a box location and a sphere location. Now we don't really need that sphere location. We just want the box location, and it just kind of spawns sprites or particles into a box. Now, this box has initial values of 400 by 400 by 100, and I'm going to change it to 100 by 100. Now, in the blueprint, what I do a lot of the times is I add a cube, or now a box collision, right? Yeah, a box collision. A box collision. Right, yeah, there is a box collision, but it's hidden hidden in the cubes. And in the box collision, I can change the stand to kind of match the system. I tend to eyeball this. So let's set it at 70, 70, 70, 70. Yeah, 70, 70, 70 should be good. Right, so now we can kind of visualize the bounding box of the particle system. Let's actually set it to 50 by 50 by 50. Yeah, 60. Yeah, that's better, right? And what I like to do is in the construction script, grab the box and set scale, set world scale 3D, and then make this a variable. So we can say system bounds and make it visible. Now, what I want to do in the level editor is basically, right, so it is set to 0 initially. So let's change it to 1 by 1 by 1. So in the level editor, what I want to do, I don't know if you can see this in stream, but there's a bounding box here. Let me just increase the line thickness. Yeah, thick lines. And it would be very handy to just change the box and have the particles, interact with the box basically. So what we can do is we can create a user parameter. Let's make a vector and let's call this bounds, right? And we're going to set this bounds from the blueprint. And this bounds user parameter is going to be attached to the box size. So let's set this vector to our box size. And then in the blueprint, we can grab our Niagara system and just say set vector parameter, like that. And then we can grab our system bounds again. This system bounds needs to be multiplied by 100. So we can multiply it with a float to get it within the same range as as Niagara. And all we need to do now is copy the bounds, copy the reference, and paste it into here, into the parameter name. So right now, in the level editor, I could basically just change the system bounds on the fly and have the particles, So now the particles spawn right inside of the system bounds, which makes world building just a little bit easier because you know exactly how big your system is and what its bounds are. And this is the first example of how to interact with your particle system coming from blueprints, right?
Yeah, awesome. Super useful. Definitely that real-time element, real-time editing is amazing.
Yeah, I tend not to work in the construction script a lot because if you do, you could mess up the actual level editor. But and then you have to revert back into a point where you didn't fuck it up for other people. But yeah, no, the construction script is really handy for this kind of stuff. Just basically have code run inside the editor without having to press play. You get to immediately see some changes. And this is one of those changes that's actually kind of handy to do in the construction script. So I can increase the size of this thing as well. Actually, let me get rid of the floor. Don't really need it anymore. And yeah, so let's actually add another actor, and let's use that actor to interact with our particle system. So let me just create a new blueprint, an actor, call it BP underscore sh, I don't know, interaction, dude. And I'm going to drag it in the level as well.
Exhibit A, trying to mute people as they come in as well.
Yeah, my ADHD tends to focus on everything all at once. So as soon as I hear something, I'm like completely distracted and I want to know what's going on. But that's just me. So right, so this blueprint, lots of cubes, needs to know some stuff from our new BP interaction dude, right? And the way blueprints can communicate with each other is basically by referencing the other blueprints.
Which in general is just a really nice lesson just to open blueprints out for a lot of people.
Oh yeah, for sure. 1 second, I'm just gonna try and mute some people myself. Who's making the noise? Sex Electro. Right. Okay. I muted him. Okay, cool. So onwards. So this blueprint contains the particle system. This blueprint we want to use to interact with our particle system with. So this blueprint needs to know some stuff from this blueprint. Actually, in our interaction dude, let's open it up and let's add an actual static mesh. So let's add a sphere so we can see it better. Right. So let's reference this interaction dude. The way I do it is also in the construction script, and I do it by finding actors. So get all actors of class.
معنی يقال نو معنی يقال أن يعطيني معنى
Yeah.
I'll try and find a way
no worries. I know how to mute people now, so I can be really quick about that. So what I do to reference this interaction dude is I get all actors of class. Then this gives me an array of all the possible actors that are in the level. But I know at this point I'm only using one. So let me just get the first one out of the array and let's store it into a variable. So this is a variable of our interaction dude reference. Here we go. And now that we have a reference set in the construction script in the event graph, I could basically on-tick get the actor location of our interaction dude. So I can drag out the pin and say get location, get actor location, right? Yeah. In Niagara, it would be nice to receive this vector. The way to do that is by creating another user variable. Let's call this one, well, let's make a user exposed variable. Let's make it a vector and let's call it dude location. And in our blueprint, we just drag out our system into the event graph, drag out the pin and say set vector parameter. Here we go. And I want to set the vector parameter in every frame. That's fine. And just connect it straight up like this. So right now the interaction dude reference is giving its location to our Niagara system. Oh, right. I forgot to fill in a parameter name. I always forget that step. And then it doesn't work. And then I'm like, why? Why didn't it work? Copy reference, paste it into the parameter name, user.dude location. And if we hit play. Yeah. But, oh, that's a lot of errors. Right. So this error happens from time to time. That's basically help. I cannot find your reference. I don't know what you're talking about. I don't know what to set. So what we can do here is basically if this is valid, is it valid? Let's check it if it's valid, and if it's valid or not, let's also create a variable and set it. So legit dude. No. Is dude legit? Is dude legit? Normally I'm better with naming variables, but not today, apparently. So in the event tick, right before we are going to set our vector parameter, we can basically ask, hey, is dude legit? And then we can say, well, if the dude is legit, then let's set some vector parameters just to get rid of that error. I don't know why. That reference didn't work the other time. Let me just expose interaction dude reference. We can expose it and interaction dude none. Well, that's weird. It doesn't want to set this variable. All right, the variable type is an actor instead of that exact. Right. Right. Get all actors of class needs to have an actual class, otherwise it just gets cast as an actor, and an actor can be anything. So for the actor class, we actually have to say get class of interaction dude. And then we get the first one out of the level, and then we can store this as, let me actually get rid of interaction dude right there. All right, then we can store this class into a variable. So interaction dude reference. This is also the fun bit about live coding is you get to see all the errors. Yeah. And that could be helpful as well. If you're watching a tutorial, then most of the time it's edited, and the person that's giving the tutorial, me included, edited out the parts where it didn't work, right? Because who wants to see that? But yeah, this could actually be helpful in a way. We can still say, we can still ask like, hey, this interaction due reference is now of type BPSH interactive dude, which is the good type. And then we ask, is it valid? And then we set it to our own bool variable. Here we go. All right. Now we can actually get our interaction dude reference, get the actor location, and send that actor location towards Niagara. So let me compile and save. And yeah, so dude is legit. You can see it in the debug. Cool. All right. So now I know that this vector param is actually is being sent over. In Niagara, there are tons of ways where you can implement this vector. Basically, everywhere. Yeah, basically everywhere. That makes Niagara so incredibly convoluted, right? They pretty much said like, hey, here's everything, and you can do everything. But that also results in kind of a convoluted UI, and it's a bit overwhelming. At least it was overwhelming for me when I first started. Now I kind of know my way around, but yeah, it's still a lot. But that's also the fun part, right? So we have a vector here, dude location, and we can implement that vector anywhere. Right now, I have a bunch of stuff I don't really need. Like I have skill sprite size, I don't need that. Skill color, don't really need that. What I would like is maybe a point attraction force. So you can't really see anything. Maybe in the middle. Maybe if I set the strength to be higher. Where is my point attraction force? Oh, right. Yeah. Okay. So it is spewing some particles around. Also the attenuation. Yeah. So it is doing something, quite something, but it is dead center, and it doesn't look good. Right. Yeah. So the point attraction force attracts particles onto a vector, but it can also push vectors outwards. If you set the attraction strength to something into below 0, basically, so minus 500, then it pushes particles out. And let's actually set the attenuation radius to something a bit lower, so it only pushes out particles with a predetermined sphere-like bound, right? So we have a location vector coming from our blueprint on event begin play, and wait. So I really thought I just created a user vector, but apparently I didn't. So let's create it again. Vector, location, dude, location. Here we go. And now let's make sure in BP lots of cubes, this is still the right. Don't know why my user parameter just disappeared, but it's back. All right, so point attraction force has a bunch of parameters, but also an attractor position. And this attractor position is a vector. And maybe you've probably already guessed what I'm going to do, but I'm going to set this to our very own dude location. So if I hit save and if I start playing, then with a bit of luck, if I grab our dude and if I push it, yeah, you can already see some particles start to move away from our actor, like that. I can increase the strength, maybe not increase the strength, but increase the attenuation radius. And more muting. All right. So right now the cubes are they're skating away like they're on ice. Basically, they never really stop moving. Well, they do eventually, and that is, you can actually control how much they are allowed to move after they've received a velocity from a force. That sounds more complicated than it is, but you have a drag module, right? And with drag, you can determine the amount of drag a particle has, and the more drag, the more it wants to stand still, unless the force is really heavy. So right now it's set to random range from float. Don't really need that. We can just directly set the drag with one float, and I'm going to set it to 10. And you can see they are less skatey. They less want to float away from everything. But we can still interact with them in this cool way, just by kind of moving our actor around. Whoop, whoop. Ah, that looks great. Okay, so yeah, that's kind of what I wanted to show you.